Need to expose a remote MCP server's tools to your AI, but the raw API is too generic or poorly documented. You'll see how to transform a remote weather tool directly in the MCP configuration, hiding unnecessary parameters, adding clear descriptions, and setting smart defaults, all without writing a single line of wrapper code. This pattern lets you adapt external tools for AI use while keeping the original server untouched.
MCP servers. Weather. URL. https://weather.example.com/mcp. Transport. HTTP. Tools. WeatherGet forecast. Name. Miami weather. Description. Get the weather for Miami. Meta. Category. Weather. Location. Miami. Arguments. City. Name. City. Default. Miami. Hide. True.
This demonstrates the tool transformation pattern, a declarative approach for adapting existing tools to specific contexts without modifying their core implementation. The pattern lets you create specialized versions of tools by modifying metadata, argument schemas, or behavior through configuration rather than code duplication. What makes this distinctive is its separation of interface concerns from implementation, allowing you to tailor tools for different clients while maintaining a single source of truth. The transformation works by wrapping the original tool with a configuration layer that defines how arguments, descriptions, and behavior should be modified. This follows the decorator principle at a higher level, where transformations are applied as declarative rules rather than imperative code changes. The framework handles the mapping between transformed interfaces and original implementations, preserving type safety and validation while exposing only the relevant details to clients. This approach solves the common problem of tool proliferation, where similar but slightly different tools clutter your codebase. Instead of creating multiple nearly identical implementations, you define one robust tool and transform it for different use cases. It's particularly valuable for AI integrations, where you need to simplify complex APIs, hide internal parameters, or add domain-specific context to generic tools. The trade-off is a slight increase in configuration complexity, but the reduction in duplicate code and improved maintainability typically outweighs this cost. Let's break it down line by line. This opens a JSON configuration object, the root structure for defining FastMCP server endpoints and their exposed tools. It establishes the hierarchical namespace where all server configurations and tool definitions will reside.
MCP servers.
This defines the root key for MCP server configurations. It organizes all external service connections in a single namespace, preventing naming collisions and enabling clean multi-server setups.
Weather.
This defines the weather server configuration under the MCP server registry. It groups all weather-related tools and connection settings under this namespace, enabling modular organization and independent scaling of weather services.
URL. https://weather.example.com/mcp.
This defines the base URL for the weather service's MCP endpoint. All tool calls to this server will route through this address, establishing the connection point between your application and the external weather API.
Transport. HTTP.
Specifies HTTP as the transport protocol for this MCP server connection. This determines how the client communicates with the weather service endpoint, using standard HTTP requests rather than alternatives like WebSockets or gRPC.
Tools.
The tools object defines the AI callable functions exposed by this MCP server. Each key here becomes an executable tool that AI models can invoke, with their parameters and metadata specified in the nested configuration.
WeatherGet forecast.
This defines the tool's unique identifier in the MCP server configuration. The key, WeatherGet forecast, becomes the callable name that AI models use to request this specific tool, while the nested object defines its behavior and parameters.
Name, Miami weather.
This defines the tool's unique identifier within the MCP system. AI models use this name to specifically request the Miami weather tool, distinguishing it from other weather tools in the same server.
Description, get the weather for Miami.
This human-readable description defines what the tool does for AI models. It appears in tool listings and helps the AI determine when to use this specific function, distinguishing it from other weather tools that might exist.
Meta.
The meta key defines tool metadata, providing additional context for tool discovery and categorization. This enables better organization in tool registries and helps AI models select appropriate tools based on functional categories or attributes. Follows the common metadata pattern for extensible tool configuration.
Category, weather.
This defines the tool's category as weather, enabling logical grouping in the MCP server's tool registry. Category metadata helps AI models filter and select appropriate tools, especially when multiple tools share similar functionality across different domains.
Location, Miami.
This defines a static location identifier for the weather tool. It categorizes this specific tool instance as Miami-focused, enabling location-specific routing or filtering in the MCP server configuration. This closing brace terminates the arguments dictionary for the WeatherGet forecast tool. It finalizes the argument definitions, ensuring the JSON structure remains valid before moving to the next configuration block.
Arguments.
Defines the input parameters for the WeatherGet forecast tool. This schema dictates what arguments the AI can pass when calling this tool, including their names, defaults, and visibility settings. The pattern mirrors OpenAPI parameter definitions, standardizing how tools declare their expected inputs.
City.
This defines the city parameter for the WeatherGet forecast tool. It specifies the input schema, including default values and visibility settings, which FastMCP uses to validate and document the tool's interface.
Name, city.
Defines the parameter name as city for the tool's argument schema. This becomes the key in the arguments dictionary when the AI calls the tool, ensuring consistent parameter identification across the MCP interface.
Default, Miami.
Sets a fallback value for the city parameter. Eliminates the need for explicit city specification in API calls, defaulting to Miami when none is provided. This is the default argument pattern for optional parameters.
Hide, true.
This hides the city parameter from the AI interface. The tool will always use the default Miami value, preventing AI agents from overriding the location while keeping the parameter in the schema for internal use. This closing brace terminates the arguments dictionary for the WeatherGet forecast tool. It finalizes the argument definitions, including the hidden city parameter with its default value. ensuring the tool's schema is complete and valid for FastMCP registration. This closing brace terminates the arguments dictionary for the WeatherGetForecast tool. It finalizes the parameter definitions, ensuring the tool's schema is complete before moving to the next configuration section. This closing brace terminates the WeatherGetForecast tool definition, finalizing its configuration including arguments, metadata, and behavior. It ensures proper JSON structure, preventing syntax errors when the MCP server parses this tool specification. The pattern maintains clean separation between tool definitions in the broader server configuration. This closing brace terminates the WeatherGetForecast tool definition, finalizing its configuration. Without it, the JSON structure would be invalid, preventing the MCP server from properly registering this tool. This closing brace terminates the WeatherGetForecast tool definition, finalizing its configuration. Without it, the JSON structure would be invalid, preventing the MCP server from properly registering this tool. This closing brace terminates the WeatherGetForecast tool definition, finalizing its configuration. Without it, the JSON structure would be invalid, preventing FastMCP from properly registering this tool with the server. This closing brace terminates the JSON configuration object for the MCP server definition. It ensures proper structure by completing the nested hierarchy of server configurations, tools, and their metadata. Without it, the JSON would be malformed and fail to parse. Tool transformation pattern. FastMCP's tool transformation layer lets you reshape server capabilities at the client boundary, where tool names become contracts and arguments become optional constraints. A transformed tool's original name still exists on the server, but the client only sees the configured alias. Debugging requires checking both sides. This pattern turns rigid server APIs into adaptive client interfaces without modifying the underlying implementation.
The argument that vanishes from the client still answers every call.